Right, the next very important rule in differentiation is how to differentiate two functions that are divided by each other. So using being introduced to the quotient rule. So quotient rule is actually in the formula booklet. I would advise you to memorize it. It's easy to memorize it if you already memorized the product rule in terms of u's and v's. So if you have a quotient, so the division of two functions, if you write them as a fraction, you will name the numerator as u and the denominator as v. And then on the top of the result, you will have almost the same identical result as for the product rule, but with a minus. So you have vu dash minus uv dash. And then in the denominator, you will have v squared. So if you think about it, try to remember it. You've got v's on the outside. So you start with v, then you've got v dash, and then you've got v squared in that order. Okay, so, and you've got a big V because V's are on the outside. Right, so let's have a look at example 12 and example 13. You've got the quotient. You're going to let your numerator be u and the denominator be v. Make sure you write it in that order. We're going to differentiate x to give you 1 and differentiate 2x plus 5 to give you 2. And then quote that no matter what, always quote it because you'll memorize it. So remember, v start from v, vu dash minus uv dash over v squared. I like to put v squared first, so it's going to be 2x plus 5 squared. Then we're going to do vu dash. Make sure you put it in that order, otherwise your marks are going to be missed. So you have 2x plus 5 times 1 minus 2 times x. Okay, or x times 2. It doesn't matter how you do the product afterwards, as long as you quote it in that way in order to memorize it. Tidy it up. You have 2x plus 5 minus 2x, so it's 5 over 2x plus 5 squared. Right, in example 13, you're going to name the top as sine x, which is your u as sine x, v as e to the power of 2x. I know I need to differentiate because I've been asked to find coordinates of the stationary point between 0 and pi. Differentiate sine to give you cos. Differentiate v to give you 2e 2x. Quote the quotient rule, so it's vu dash minus uv dash over v squared. So v squared goes on the bottom, so it's e to the power of 2x squared. Write it like this. And then you've got vu dash. I'll do it actually long way. E to the power of 2x times cos x minus uv dash. So you've got sine x times 2 to the power of e 2x. Right, the reason you don't need to tidy it up further is because you're using this result to find the coordinate of the stationary point. But so you're going to make it equal to 0. Okay, so dy dx is equal to 0. So if it's a fraction and you are considering when it's equal to 0, you just need to, you don't need to tidy it up yet. You might wish to just need might as well 2e to the power of 2x sine x over e to the power of 2x over that squared. You can write it as e to the power of 4x, but because I'm going to make it equal to 0, you need to consider the fraction is equal to 0 only and only if the numerator is equal to 0. So we need to solve this equation so the numerator is equal to 0. Okay, so let's just rewrite it on the next page. We've got e to the power of 2x cos x minus 2e to the power of 2x sine x, and that's equal to 0. Just double check. Okay, so this is the numerator. Okay, remember, if you've got, if solving this equation, this will only happen if the numerator is equal to 0. Okay, so over here, let's factorize the e. Okay, so you've got the product of these two terms equal to 0, where either this is equal to 0, that's impossible, because e has an asymptote at 0, and or the bracket is equal to 0, which happens where that's equal to, let's write it down, cos x minus 2 sine x is equal to 0, which happens when cos x is equal to 2 sine x. Divide by cos x, you will have 1 is equal to 2 tan x. So tan x is equal to a half. So let's do tan inverse of a half. So that gives us the x coordinate on that point. 0.464 radians. Y is going to be equal to, so the function was sine x over e to the power of 2x. So that's going to be sine 0.463 etc. over e to the power of 2 times 0.4636. Use the ans key on the calculator. So have sine ans over e to the power of 2 ans. That gives me 0.1769, which is 0.177. Okay, we haven't been asked to check what type of stationary point this is. We just need to state the coordinates. Okay, so you can have a go at exercise 9e. Oh, before you go, I'm just going to show you something with the in case you need to tidy up the expressions in the previous example. It's just a good idea to have a little go at doing this. So in the previous example, we had to differentiate sine x over e to the power of 2x, and we obtained e to the power of 2x cos x minus 2 e to the power of 2x sine x over e to the power of 2x squared. There you go. So what you can do with the numerator, you can factorize e, and that will be a common thing to do in those questions. And in the denominator, you might write it as e to the power of 4x. And then you need to consider the cancellation of these two, which will be e to the power of 2x divided by e to the power of 4x. So it's e to the power of 2x minus 4x, which is e to the power of minus 2x. There you go. So you could write it without the denominator as bringing that to the top, and again that could be something that you ask to do, or you can write it with e to the power of 2x in the denominator. This is only necessary if they ask you to do it. in order to answer the question before, you did not have to do it. I know the book did it anyway, but it just, that will be just an extra. Okay, so off you go and do exercise 9E.